everyone, today we're going to head and take a look at lesson 4-8, Quadratic Inequalities. This is the last lesson in chapter 4, and as usual, pause as needed. If you need more time to take notes, to work things out, go ahead and pause and then restart the video when you need to and are ready to. Also, it might be a good idea to go ahead and have access to some type of graphing calculator, whether it be a physical calculator that you have or an online version of one. You might find helpful today. So without further ado, we're going to head and start with example 1. We have graph y is greater than x squared minus 3x plus 2. So the thing with these are, if you actually are told to graph one and you need to plot coordinate points, generally on most graphs, if you want a table of some sort, you do have to go ahead and graph the quadratic equation. So in this case, it would be y equals x squared minus 3x plus 2. That way you can get some coordinate points and plot them and then go ahead and shade where we need to go ahead and shade, because we're not generally going to be able to do that if you just graph the inequality. So we go ahead and graph our y equals x squared minus 3x plus 2. And because we have a less than or greater than symbol, there is no equal to, our line will be dashed. So then we're going to head, if you're doing this by hand, you're going to pick a coordinate point, test it, and see if it gets you a true or false statement. If it's a true statement, you're going to shade that region. If it's a false statement, you're going to shade out not the other region that's our option. So we're going to head and test the coordinate point 1, 2. Another good coordinate point that is good to test is actually 0, 0. Is another one that we tend to also like to use. But we're going to use 1, 2 in this case. And so we have 2 is less than 1 squared minus 3 times 1 plus 2. So when we go ahead and simplify, we get 2 is greater than 0. That is a true statement. So we are going to shade in the same region that the coordinate point 1, 2 is located. So we're going to shade on the inside, and any coordinate point in that shaded region would be a solution point. All right, so go ahead and try graphing y is less than negative x squared plus 4x plus 2. Pause so you can have some time to go ahead and try it. All right, so here we have 4 options, and the nice thing with actually this one, you actually get to see if they used any of the 4 inequalities. These are 4 options of what they could actually look like, because the quadratic graph is actually the same. So we're looking more for the solid or dashed and then shading. So because it's just a less than greater than, we are not going to use A or B because those are solid. So I'm not equal to. So then the question is, do we shade inside or outside? So we're going to go ahead and use the coordinate point 0, 0. I'm going to plug in 0 for y and x. So we have 0 is less than negative 0 squared plus 4 times 0 plus 2. And that becomes 0 is less than 2. That is a true statement, so we are going to shade in the region that contains 0, 0 or our origin. So if I compare the two, we're going to go ahead and go with D. Taking a look at example 2, we have solve x squared minus 4x plus 3 is less than 0 by graphing. So the solution consists of x values for which the graph of the related quadratic function lies below the x-axis. So we're going to start by finding the roots of our related equation. So we're going to go ahead and factor for x squared minus 4x plus 3, and we get x minus 3 and x minus 1. So by using zero product property, we get that x is 3 and x is 1. So then we're going to head and sketch the graph of the parabola that has x-intercepts at 3 and 1. The graph should open up since a is greater than 0. And since the graph lies below the x-axis to the right of x equals 1 and to the x equals 3. So that means the solution is x such that x is greater than 1 but less than 3. So our answer is the shaded region that's below. So which x values would work? So what is the solution to the inequality x squared plus 5x plus 6 is less than 0. I'll go ahead and give you time to try that one. All right, so taking a look here, we are going to go ahead and factor, and we get x plus 2 and x plus 3 when we go ahead and factor. And we want these to be less than 0, so we're going to use zero product property because we use equal, and we get x equals -2 and x equals -3. So when we graph it, we do see that below it's between -3 and -2. So -3 is less than x, but x is less than -2. So our answer is A. All right, next we're going to go ahead and take a look at 0 is less than or equal to -2x plus 2 minus 6x plus 1, and we're going to solve by graphing. So we're going to head and find our roots. So the solutions of these lie on the x-axis, so we're going to look for those. In this case, we are going to use the quadratic formula because it's going to be easier to do it that way. And so we identify our A, B, and C values. A is -2, B is -6, and C is 1. So we substitute those values in. Once we simplify, we do get 6 plus square root of 44 over -4 and 6 minus square root of 44 over -4. And then when we go ahead and get an estimate of those, we get -3.16 and 0.16. So if we can sketch our graph, and we do see they are about those areas. So we're going to say our solution is x such that x is equal to or greater than -3.16, but less than or equal to 0.16. And of course, you can always check these. You can go ahead and we're going to pick a value that's less than -3.16, one that's between -3.16 and 0.16, and then another one that's greater than 0.16. So they're going to test -4, and we find that doesn't work. They test 0, it does work, and then we test 1, and we find that it doesn't work. So it only exists between the two values. So go ahead and try 2x squared plus 3x minus 2 is greater than or equal to 0. You can try by graphing it. All right, so what we're going to when you graph it, here's what our graph is. And we can see that it's above from here, from this point and this point we want, because it says greater than, we want above. And then if you use the quadratic formula, you will get -2.77 and 1.27. What you would plug in to get that would be -3 plus or minus the square root of 9 minus 4 times 2 times -7 all over 2 times 2. And the 9 is 3 squared. So that's how we get that. You would plug that in, and those are about what they would simplify to. All right, for our next example, we have a real world situation. The height of a ball above the ground after it is thrown upwards at 40 feet per second can be modeled by the function h of x equals 40x minus 16x squared, where the height h of x is given in feet and the time x is in seconds. At what time in its flight is the ball within 15 feet of the ground? So I want to know, when is it from 15 or lower? When does that start? So we're going to find the values for x for which h of x is less than or equal to 15. So we go ahead and set that up. We're going to start by subtracting 15 from each side so that we can go ahead and factor or find our roots of the resulting inequality of -16x squared plus 40x minus 15. So we're going to go ahead and graph that. This would be one you might want to go ahead and use Desmos on, or your physical calculator. Desmos will automatically mark your intercepts, and so you should see they will tend to round to the third decimal. Here we're rounding to the second, so it's between 0.46 and 2.404 seconds is where our roots are. So the ball is within 15 feet of the ground for the first 0.46 seconds of its flight, and from 0 to 0.046, and again after 2.04. So until the ball hits the ground at 2.5. So let's go ahead and try this one. The height of a ball above the ground after it's thrown upwards at 28 feet per second can be modeled by the function h of x equals 28x minus 16x squared, where the height of h of x is given in feet and time x is in seconds. At what time of its flight is the ball within 10 feet of the ground? So I'll go ahead and give you guys a moment to try that one out. All right, so let's go ahead and take a look at this one. So we're going to go ahead and set up we want to know when h of x is less than or equal to 10, because that would make it within 10 feet. So we have, when we write it out, we have 16x squared plus negative 16x squared plus 28x minus 10. It's going to be less than or equal to 0. So we are going to go ahead and graph this function here. So I'm going to head and switch over to Desmos to show you that one. So here we are. We're going to type in negative 16x squared plus 28x minus 10. So we're looking for when it hits 0. And we get at 0.5 and at 1.25. And so with that, going back to our question, we see that point for the first 0.5 seconds, and again after the 1.25 seconds, we're going to go with A. All right, let's go ahead and take a look at solving algebraically our x squared plus x is less than or equal to 2. So first we're going to solve the related quadratic equation. We're going to head and subtract 2 from both sides and go ahead and factor to get x plus 2 and x minus 1. And using zero product property, we're set each factor equal to 0 and solve for x. And we get negative 2 and 1. So we're going to plot negative 2 and 1 on a number line and use closed circles since we do exist there with the equal to symbol. So that we have 3 sections. We're going to have the values that are less than negative 2, between negative 2 and 1, and then greater than 1. So we're going to test something from each of these and see which one works. So in this case, they tested negative 3, 0, and 2. And when they did that, they found only 0 works. So my answer is going to be negative 2 is less than or equal to x, which is less than or equal to 1. And if you wanted to see it shown on a number line, this is what it would look like. All right, go ahead and try x squared plus 5x is less than or equal to negative 6. Pause the video as needed so that you have time to work it out. All right, taking a look here, we have x squared plus 5x is less than or equal to negative 6. So I'm going to add 6 to both sides. And we did this, we've actually factored this one earlier, and it ends up being x plus 2 and x plus 3. So I do know the roots are going to be x equals negative 2 and x equals negative 3. So on our number line, we're going to go ahead and set this up. Here is -2. Here is -3. So I am going to go ahead and change colors. Let's go ahead and go to black. So we do know there's going to be closed circles. So I'm going to test. Oh, I'm sorry, I did this in the wrong order. This should be -3, and this should be -2. So I would test -4, I would test 0, and I would test -2.5, which is going to be the same thing as -5/2. Because we might find that's easier to go ahead and do that. And once we test those, I find that -4 does not work, 5/2 does, 0 does not work. So showing you that, if I use x squared plus 5x, is less than or equal to -6. If I use 0, I get 0 is less than -6. That does not work. And then I can do -4, so that would get me 16 minus 20, less than or equal to -6. And I'm going to get -4 here. -4 is not less than -6. It's actually greater than that. So that does not work. And then I'm going to use -5/2. So squaring that would get me 25/4. Plus, actually it's going to be minus 25/2. So 25/4 is the same thing as 5.25. I wanted to double check that. Oh, 6.25. So this would be 6.25 minus 25/2, which is 12.5. And we get -6.25, which is less than -6. So that is why only the middle term works. And with that, we get A. That is the end of the notes, and I will see you next time.